Good morning, students. The pujas are over and exams are nearing by. So, again, we have to tie our belts and set for a new journey, everybody, for the exams. Now, since I am actually focusing on ICSE students mainly and CBSE, that's why I always deliver my little lessons in English. For you all, today I am going to discuss upthrust and Archimedes principle. This portion has already been covered in class 7, I feel, or in class 8. And now again in class 9, you all are going through the same subject. The whole thing is, whatever concept is there, it's very little. You all have to understand the concept. Only then the numerical problems. What do we know about upthrust? We know that any object, when it is immersed in any fluid, it experiences an upthrust. The force experienced by that object in the upward direction when it is immersed in a fluid is upthrust. Now, this upthrust depends on what factors? First, let us think about certain examples. In fresh water, you all know, in some time or the other, you went for a swimming or just you dipped yourself in the pond. You know, if you don't know swimming, a person can get submerged completely in water. But at the same time, you have also learnt in your geography that in Dead Sea, nobody actually drowns. So there is something in Dead Sea that lifts the object up, the person up. But in fresh water, in river water, people drown. They don't keep themselves afloat if they don't know swimming. So when you know all these factors, what you have to keep in mind is the upthrust on any object has a great dependence on the density of the liquid in which that object is dipped. Any object in whatever liquid it is dipped, that liquid matters. In river water, you know, river water has a density much less than seawater. Moreover, in Dead Sea, the density of water is so much that it can keep almost everything afloat. So, the upthrust on an object by a fluid depends upon the density of the fluid. Number one. Number two is, whatever object you dip inside that fluid, how much you dip that object. That volume of that object matters. The volume of the object that you dip, if it is dipped completely, that will make that same volume of object to displace water. The amount of water displaced by the object depends upon the amount of the object or the volume of the object that is immersed. If you completely immerse the object, the whole volume of that object will displace the liquid. If you partially dip that object, that partial volume of liquid will be displaced. So the volume of liquid displaced is a very important factor to bring the upthrust. Let us explain another example that we have in our book. In our book also, we have learnt in class 7 or in class 8 that an iron nail completely immerses itself in water or gets drowned, but a big ship made out of iron. It is afloat. Both are made out of iron. Now that iron nail, just imagine the volume of that iron nail. How much liquid will it displace? And imagine the whole volume of the ship. The huge volume of water that the ship is going to displace is creating the necessary upthrust so that the ship can remain afloat. Now, to understand the concept very clearly, we have shown an object which is dipped inside some liquid. The weight of the object acts vertically downwards, while the buoyant force or the upthrust acts upwards. Now, let us determine what will be the apparent weight. After knowing W, B, how to calculate the apparent weight. This W is the actual weight of the body, B the buoyant force, and W dash is the apparent weight. What is the apparent weight? Apparent weight is the weight experienced by the body when it is still inside this liquid. While inside the liquid, do we feel our same weight? No. When we are actually getting inside some river or a pond, we know very nicely. As soon as we get inside the water, we feel our body to be light. That feeling is that apparent weight. Okay? Now, W dash apparent weight can be calculated when we subtract the buoyant force from the actual weight. Because W is acting downward, B is acting upward. So the net force, apparent weight is nothing but the net force. The net force acting downward is the apparent weight. That is actual weight minus buoyant force or upthrust. This buoyant force is called the upthrust, and the same thing is equal to weight of the fluid displaced by the immersed part of the body. As you can see, the buoyant force, which has been termed as upthrust, is actually weight of the fluid displaced by the immersed part of the body. The buoyant force depends upon two factors: density of the liquid in which the object is immersed and the volume of the immersed part of the body. Now I have a question for you. If a particular object is first immersed in milk and then in mercury, express in which liquid its apparent weight and upthrust will be more. Now think about milk, its density, and then think about the density of mercury. The density of mercury is more than the density of milk, which makes the upthrust in milk to be less. See, it is the same object. It is the same object. First, it has been dipped in milk and then in mercury. If the object is same, the weight of that object is same in the two cases. In the two cases, the object has the same weight, but the upthrust differs. That object is completely being immersed both in milk and in mercury. So the volume of milk displaced or the volume of mercury displaced is same, but the densities are different. So upthrust in mercury will be more and upthrust in milk will be less. So upthrust is more in mercury. Keep that in mind. Since mercury is denser than milk, the upthrust in mercury will be more. And we also know that apparent weight or net weight can be calculated by subtracting the upthrust from the actual weight. So if upthrust in milk is less, so apparent weight in milk, apparent weight W dash in milk is more than in mercury. That means the object feels heavier in milk than in mercury. So when you think about all these things, be very clear about the fact that the density of the body plays no role in upthrust. The density of liquid is the very important factor in creating the upthrust, and the volume of the immersed part of the body. These two things have to be kept in mind when you calculate the upthrust and apparent weight. And coming to Archimedes principle, we can have a separate video for that, and we can do problems in Archimedes principle also. What is Archimedes principle? Archimedes principle is, it states that when a body is partially or wholly dipped in a liquid at rest, it experiences an upthrust which is equal to the weight of the fluid displaced by the immersed part of the body. Please go through the lessons, and if there is any query, please let me know. Thank you.